So now you get to learn how to deploy your Bottle web application. So we've gone through how to create a Bottle web app, how to create static files, how to create templates, how to do all of those things, and you've been using your Bottle web app within a testing environment. Now what we're going to do is we are actually going to deploy our web app up to the internet itself so that basically anybody in the world will be able to have access to the app that you created. So that you fully grasp what we're going to be doing in this particular session, this is my control panel that is opened up on DigitalOcean. So DigitalOcean is an infrastructure as a service platform. Basically, it allows you to be able to create virtual servers and that type of thing. And I have created an Ubuntu virtual server up on DigitalOcean, and it has an internet addressable IP address. That means it's able, anybody on the internet is able to connect to it, of 165.232.148.27, right? If we come over to Safari on my computer, and I don't know if you can see up here, we go to 165.232.148.27, we can see our amazing web app. Hello world, we're telling the entire world hello. And the cool part about it is, not only can we go to it from our computer here, but if you can see on my iPhone, again, going to the exact same IP address, we can see we are telling the world hello, and this is basically what we're going to be deploying today. Now, one of the big things to understand at this point when we go to deploy a Bottle web app is you are going to need to understand a little bit more of the stack, the technology stack, than we've necessarily taught in this series, right? So before you got in this series, you should understand Python, you should understand HTML and CSS, and I taught you how to use Bottle and the template languages and such in this particular course. The thing is, in order to deploy a Bottle web app, you will need to know a few more things, such as basically how to do basic administration of a Linux operating system. So when we go to DigitalOcean, we're going to create an instance of an Ubuntu operating system, and then when we do that, what we're going to be doing is we're going to be installing Nginx, which is a web server. We are going to be creating a service which will automatically start our Bottle web app. We'll be creating a user account, doing a couple of those types of things. So it's not complicated. No, it's not horrible, right? If you understand Linux, you should be able to follow along. If you don't understand Linux, it might be a little bit more difficult, but that is the fun of the technology world. So if you're going through this particular class and you don't understand the Linux components, you just have to basically bone up on Linux so that you understand Linux a little bit better. We are going to be using DigitalOcean today. I find DigitalOcean to be a good platform, especially for educational environments, because it is dirt cheap, or it's relatively cheap. We pay $6 a month for the instance that I'm showing you here, and it's relatively easy to use. Again, there are other platforms out there, but they can be more difficult. And again, remember, the bias of Silicon Dojo is to find like a default standard, and DigitalOcean is kind of like that good default standard to go to. So that's some of the things to be thinking about as we go through this today. Just realize we are going to be dealing with the Linux operating system. Again, we're going to be talking about some of the networking components, that type of thing. And so if that kind of thing is over your head, it's okay. You're not dumb or anything. You can learn that. You just may have to learn that in a different series of classes. Now, before we actually get into deploying the code and all of that, let's talk about my favorite subject, architecture, so you understand logically what this is going to look like. So one of the things we're not going to be dealing with today is DNS, basically a fully qualified domain name. So when we talk about that, that's google.com, that's silicondojo.com, that's eliTheComputerGuy.com, right? Basically, what you're able to do with DNS is you are able to register a domain name that you've purchased, and then you're able to point it at an IP address, right? So that IP address that I was showing you here for Hello World, 165.232.48.27, I could point, let's say, crappy-app.com, that's one that I own, to that IP address, and then anybody who went there would get Hello World. Again, that is a bit out of the class today, so we're not going to be doing that, but that's all there is there. Past that then, right? So we're going to have a user here. They are going to connect to the internet, and basically they're going to go to the IP address that you have for your server, and that is going to come out onto DigitalOcean, right? So that is going to go into DigitalOcean's big old data center that is somewhere. Basically within that data center, again, you are going to have an Ubuntu instance. This is called a VPS, a virtual private server. On this Ubuntu instance of a virtual private server, we are then going to have a web server called Nginx. Nginx. It'd be good if I can spell something so simple. Anyways, we're going to have the Nginx web server. When you hear about web servers, there are a lot of different web servers out there. Apache 2 is kind of like the default standards for the not boomers like me. I've been using that one for 25 years at this point. If you're in the Microsoft world, there's something called IIS, Internet Information Server. Light, LIGH, TTPD. Anyways, there's a lot of different, basically, web servers out there. So the question is, why are we using Nginx? And we are using Nginx for the same reason we're going to do most things in the technology world, because we are told that's the one we're supposed to use. Because basically the traffic is going to come in to Nginx, and Nginx acts as something called a reverse proxy server. And this reverse proxy server has a bunch of configurations and tools in it to basically make the traffic between the server and the visitor basically work more seamless, caching systems and that type of thing. So this is basically what's called a reverse proxy server. That is then going to connect to the Python web server called Gunicorn. So there's a Python web server that, yes, is called Gunicorn, and that is what Nginx is going to connect to. And the reason that we're going to be using Nginx, the real reason we're going to be using Nginx, is because Gunicorn prefers Nginx. So again, that's how it goes in the technology world. So Gunicorn is going to be presenting the web application to Nginx. Nginx is going to do this fancy reverse proxy stuff to make the communication traffic better to the visitor. Basically, Gunicorn is going to be presenting your Bottle app, so that web app that we created using Bottle and Python. Basically, Gunicorn is going to be turning that into the web app so that it can be presented, which goes up to Nginx, which goes out to the visitor. The interesting thing is we're going to be creating a service. So basically, within the Linux box, we're going to be creating a service. So when the computer restarts, this service will restart, and basically Gunicorn is going to be presenting this web application at a particular port. I think it's port 8000 when we do the configurations. So basically it'll be like 127.0.0.1:8000. So when the computer boots up, your Bottle app is going to be presented at 127.0.0.1:8000 for the port, and basically Nginx is going to point visitors to that when visitors come in, and then they will get the Hello World web app that will come back to them. And that is basically how the architecture of this system works. And so it's good. Like, the more you understand about how the architecture works, the easier it is to build and troubleshoot. So you will hear about something called the OSI model, right? The OSI model is a 7-layer model. Layer 1 is the physical layer, network cables. Layer 2 is the switch layer, the link layer. Layer 3 is the networking layer. Anyways, when people hear about the OSI model, one of the big problems is that they think they're only supposed to learn the OSI model in order to be able to pass a test. Like, oh, it's crappy, this sucks. I'm learning the OSI model to pass a test. That's not why you learn the OSI model. Why you learn the OSI model is so that you can break these systems down logically so that when you have a problem, you know where to go to try to figure out how to troubleshoot, right? If you just have this mass of a web app and there's a problem, what are you going to troubleshoot? Nginx? Are you going to troubleshoot Gunicorn? Are you going to troubleshoot Bottle or Python? Are you going to troubleshoot Ubuntu? Are you going to troubleshoot some configuration on DigitalOcean? Where do you start? See, the thing is, the more you understand how the architecture works, you're like, oh, this is the problem that I'm having. Okay, the visitor is able to get all the way to the Bottle app, but once it gets to the Bottle app, then they get an error that the route doesn't exist. If the route doesn't exist, again, for the routes, that means that's a Bottle error right there. If we're able to get to the server and we get something called a 500 error, that's a server error in Nginx, then we know there's something going on between Nginx and Gunicorn that basically the website is not able to present itself. If we try to go to the site and you get nothing, right? You just get the cannot connect to site, then we know that there's something wrong with the IP address or DigitalOcean or maybe your firewall or something like that, right? So being able to break down these individual layers of the stack makes it easier for you to be able to troubleshoot when you screw up. Now let's have a couple of more notes on this tech stack before we dive in. One of the first things is we are going to be using Ubuntu with DigitalOcean. One of the quirks, and that's what you find out in technology world, everything has quirks, about DigitalOcean is when you create a VPS with DigitalOcean with Ubuntu, it will automatically create a root account for you and you will log into that root account. Now that's the thing, normally when you install Ubuntu, and almost every other situation with Ubuntu, it's one of the things that Ubuntu is famous for, is that you don't log in as the root account, that in order to do any kind of administrative tasks, you have to use sudo in order to be able to change anything. Well, with DigitalOcean, nope, you're logging in as Linux root. And so the big thing for you, just from basic administrative tasks, is generally you don't have to type in sudo. But the other thing is we're going to be creating a user account for our app when we're building out this project. And one of the reasons we do that is because we don't want to use the default account that DigitalOcean uses, because the default account is the root account. So if somebody can compromise your web app, they literally have root access to your entire system. So that's going to be one of the quirks there. The other thing is, again, we are doing a very, very simple web app, right? Of just saying hello world. So we're not dealing with the views folder, we're not dealing with the static folder or any of that kind of thing. If you're going to create an app that has views and has the static files and has other things, you will have to make sure that the visitor will have permission to view or be able to interact with the files that you've created. So there's something called the chmod command, basically allows you to modify the permissions or privileges for files and folders within your Linux system. So if you basically are creating a more complicated web app and then you start getting like X's where images are supposed to be, or you get other weird kind of like, cannot be found errors, one of the issues might be, again, is that Linux permission deal that we're not going to be dealing with today. Again, that will be for another class. So that's one of the things to remember. The other thing to remember, again, even if you've been using for Linux for a while, this is an easy one to forget, is when you modify any files on Linux, again, that are part of services, realize those changes will not be active until you restart the service, right? So one of the problems that you can have is, again, when we create the service and we do some other things, again, you may fat finger, you may just, all right, you do something stupid, you fat finger it, you try to make it run, or it's running but it's not running properly, so you go back, you modify it, you make it right, but then you're still getting an error, and you're like, I don't understand. The reason is because you need to restart that service. You need to restart it. If you don't restart it, then the changes are not going to come into effect, and then you're basically going to be sitting there for 5 days troubleshooting something that you fixed within the first 5 minutes. So that is something. Always make sure to restart services. Whenever you make a modification in Linux, restart whatever the hell that is you're working on. So when we interact with Nginx, we will restart Nginx. When we interact with Gunicorn, we will restart Gunicorn. When we create the service, we'll restart the service. You always want to make sure that you're restarting. When in doubt, maybe just reboot the entire system, verify everything got restarted, because that can be a major issue for people. Now, the first thing that we need to do as part of this whole configuration process is create a virtual environment, and then from that be able to export the requirements.txt file. So this is a big thing. A lot of times in Silicon Dojo, when we're dealing with Python, I do not deal with virtual environments because it is simply an extra layer of complication that generally makes people confused. They get confused and then they give up, and that's a bad thing. Again, we always try to keep things as simple as possible here when we're teaching you. The thing is, now we're kind of getting out of the teaching world. We're actually getting into the quote-unquote deploying world, into the enterprise. So we got to be a little bit more serious here. And so that's why we're going to be using a virtual environment. So a virtual environment is essentially a container for all of the modules and packages that your particular project needs. So basically what you're able to do is you're able to create this container, you activate the container, and then your script will be able to run inside that container and use any of the modules that happen to be in that container. So this could be useful, again, for testing and troubleshooting purposes, especially if you're using open source modules. There may be like multiple versions of the exact same module out there, and for one project you need version 1, and for a different project you need version 3. That's one of the nice things about using virtual environments, is because basically you can containerize it, so this project will use version 1 and this project will use version 3. Anyways, when you actually go to deploy though, this is a best practice by and large for whenever you're going to be deploying. So even when you're going to be deploying to something like DigitalOcean and you're only going to be deploying one web app to that VPS, to that virtual server, it's still a good idea to use VENV, virtual environments. The big thing that you're going to run into, and again, wait for it, is also that basically that's all the documentation. So if you run into problems, so if you're doing this and you're trying to figure out what's going on and you can't figure out what you're screwing up, here's the thing. When you go to look for documentation on how to deploy a Bottle web app, they're always going to tell you to use a virtual environment. And if you try to do it without using a virtual environment, that's a bit of its own misery. So one of the reasons we're also using a virtual environment here is because that's what all the documentation says to do. And again, we're trying to keep this simple if you try to go and troubleshoot it. So basically what we're going to do is we're going to go into our current working directory, wherever our web app is. We're going to do Python 3 space -m VENV space VENV. So this is going to create a virtual environment of named virtual environment. So we should already have that virtual environment module installed from one of the previous classes. So we had a previous class where we installed the virtual environment. We should have that there. We're then going to activate the virtual environment. So source VENV bin activate, so that activates the virtual environment. And then we are going to install the modules that we care about. So for this, we're going to need to install the Bottle web app framework, and we're going to need to install Gunicorn, and that is going to be that Python web server. We're then going to install whatever other modules we need for this particular web app. Again, OpenAI, requests, whatever that is, and that will all be within that container. Then what we're going to do is we're going to do pip freeze arrow requirements.txt, and it's going to take everything within that virtual environment and it is going to basically save it as a requirements.txt file so that when we create a virtual environment within the DigitalOcean world, we can then import all of those modules and there shouldn't be any issues. So today we're going to be interacting basically all through VS Code to do everything that we're going to be doing. So we have VS Code, we have our code open here, we have our terminal open here, and we have our workspace open here. So our workspace is open to the desktop. That's just the folder that I'm using for while I'm teaching you. And if you can see it, there's a static folder, there's a views folder. I'm not worried about those today, but we have that example.py script, and this is going to be our hello world script. You will notice there is no VENV folder here yet. So what we're going to do is we're going to go to the terminal. And so this should be at the terminal, so it says desktop, so I'm at the desktop, so this should be whatever working directory that I should be at. And from here, I'm going to type in Python 3 space M VENV space VENV, right? So this is calling the VENV module and creating a virtual environment called VENV. We hit enter. We notice the environment has been created. Yeah, we'll use it. That's fine. Okay, and so if we take a look up here, we now see that the VENV folder now exists up here, right? So that's what we want. So then we're going to come back down here again, and from here I'm simply going to say source VENV, so I'm going into that folder, bin /activate, and so this is going to activate the VENV that we created, and now we see this nice little prompt here that says VENV. Now that we have that, what we need to do is we need to install whatever modules we need for this particular web app to work. So basically, all I want to do here is I can do pip install, and let's say Gunicorn. Install Gunicorn. Pip install Bottle, and install Bottle, and let's just do pip install requests. Just so we can see we can install something else, right? So now we have Bottle, we have Gunicorn, and we have requests installed. Then from here, what we are going to do is we are going to use the pip freeze command. So we do pip freeze. Shrink that a little bit so you see it, freeze, and then you do that little arrow thing, and then we say requirements.txt. So what this is going to do, so you can see it's all on one line, right? It's all on one line, is basically it's going to take everything within that container, it's going to freeze it, and basically it's going to save everything that's in there to the requirements.txt file. We're then going to hit enter, and then if we enlarge everything here, we now see we have the requirements.txt file. If I select on that requirements.txt file, basically this is all that's in it. Bottle at this particular version, Gunicorn at this particular version, and request at this particular version. So when we import the modules, when we're over to DigitalOcean, it'll just basically take this information and then it will install it within the virtual environment within DigitalOcean. So now before we go over to DigitalOcean, let's take a look at our web app script itself. So again, our script is going to tell the world hello, right? From Bottle, we're going to import run. Run isn't actually used for when you're deploying your app into the real world, but it will be used for testing purposes, that type of thing. So we're going to need that function now. A route is definitely needed because that's basically how routes work. And this thing called default app. And so this is what's going to give our app an actual name. And we'll deal with that later when we're dealing with Gunicorn. So basically we'll point it to the example script :app name, and this is what's going to give us that app name. We have a route, so at route of root, define index, and all we're going to do is return h1 hello world. We're going to tell the world hello. Now we're going to come down here to this if statement. So we've talked about this before in a previous class. So normally when we've been basically playing around with Bottle, you don't have the if statement, you just have the run basically function there. Basically what this is going to do is this is going to say if this script is triggered by itself, or basically if this function is triggered from this script, then this will be able to run. If the script is basically triggered from something else outside, then don't do this. So what this means, right, if I go and I click on run right now, so basically I click on that little run button up there, we can come down and we can see listening on 127.0.0.1, 8,000 like we've seen before, right? But here's the thing. When Gunicorn, so again we talked about that text store, when Gunicorn goes to connect to this thing, we don't want run to trigger or it's a bit of a disaster. So basically with run here, what will happen is run will try to run its own instance of this, and then all of a sudden you have Gunicorn trying to run the web app, and you have Bottle trying to run the web app, and quirkiness ensues. Quirkiness, horribleness ensues. So we don't want that. So that's why we do this if statements here. So if, right, this is a global variable for Python. So this is a built-in variable. So basically we say if name, so if the name of the script as Python see it equals main. So again, that is that you triggered the script yourself. You did Python 3, example.py, or you hit the run, then run this function. Else, Gunicorn is triggering this thing, don't do this, right? That's very important. If you deploy your Bottle web app and it's just quirky, again, hard fails are easy to figure out because it just doesn't work. It just doesn't work, so you know to troubleshoot. Soft fails, where it kind of works, but not very good. This is one of the issues. You might have a soft fail of basically Bottle is trying to run it itself, the app itself, and Gunicorn is trying to run it at the same time, and disaster. Anyways, so that's there. Again, if you try to run it, if you're able to run it locally, again, host at 127.0.0.1, port equals 8080 if you're going to be doing this just from the script itself. Then we have app, right? So this is the name that Gunicorn is going to be attaching to, and we'll deal with that later. So basically, when we use Gunicorn to interact with this Bottle web app, you need to give it the Python script name, and you need to give it the app name. I think the easiest way of doing this is simply using this default app function. So basically app equals the default app function. So this name basically is what we're going to use to identify this entire script. There is a different way of doing this, but I do think this is simplest. So now let's create our droplet on DigitalOcean. Again, everybody has different names for things. So a VPS, a virtual private server, is kind of like the standard name for an instance of a server on one of these platforms. On DigitalOcean, they need something to copyright, so they call it a droplet, right? So depending on your screen and how you've been using DigitalOcean, I don't know where this will be, but basically what you want is this here of spin up a droplet, whatever the hell that may look like, right? So we're going to click on that there, and then we are going to get this per page for creating droplet. So the first thing it's going to ask you is your region. Now this is a Hello World app. It doesn't matter. This app doesn't matter. If you're doing a more complicated app, do realize that the closer your server is to the visitor, to the end user, the faster the process is going to be. So that's one of those things to consider. So in the US, using San Francisco is fine. San Francisco or New York, it doesn't matter, even though I'm here in Nashville. If you're in Europe, I would use like Frankfurt or Amsterdam, right? If I was in Canada, I might use Toronto. If I was in like New Zealand or Australia, I may use Sydney. These are things to consider later when you're actually deploying like a real app. Today, probably just leave it in San Francisco and you're going to be fine. It says the data center's there, VPC, that's fine. Then we're going to come down to the custom images, right? So we have Ubuntu, Fedora, Debian, CentOS, Alma Linux, Rocky Linux, a whole bunch of Linux. We are going to use Ubuntu. Why? Because it's a good default standard. We like to standardize here at DigitalOcean, and Ubuntu, it's one of those things we've been using for 18 years now. Is just easy. You're going to see a version here. Now, again, for your particular situation, you might need a different version. And if there's not a reason to mess with a different version, don't use a different version. Then we're going to come down here, choose type, droplet type. You can have like different dedicated type CPUs. Like if you created a web app that was going to be using artificial intelligence, let's say you were going to use Llama directly on your VPS, you might want to mess with all of this. This is stuff to play with. Again, we are saying hello world. We don't want to worry about any of that. So we're going to say basic for the droplet type. We're then going to come down here. It's going to give you CPU options. Premium AMD, premium Intel. We are going to go to regular, because we're simply saying hello world, and we want to pick the $6 version. Again, this is one of those things you have to be careful about, is you hear about $4 or $6 VPSs, but you'll notice they default you to $24 a month, right? They have the cheaper version, but you probably want that. We don't, we're just simply saying hello world. You will notice there is a cheaper version of a droplet at $4 a month. What I have to tell you is I'm not sure what this $4 a month droplet is for. I will tell you it exists, and it runs not well for almost anything. I'm not sure I would trust it to say hello world. For whatever reason, $6 a month for a simple bottle web app, that works wonderfully. So again, when you use the $4 a month, even using things like SSH, like gets bad, it's bad. So just pay the $6. You don't need to pay $12. You sure as hell don't need to pay $18. Go for that $6 a month thing. Then it come down, it'll ask you for additional volumes. We don't care about that today. This is going to be the big one. Choose the authentication method. So again, in a real production environment, you would want to use something called an SSH key. This class is hard enough to teach as it is, so we are going to use password. So when we use VSCode to connect to our DigitalOcean server, we will be able to plug in a username of root and a password of whatever it is that we decide. So I'm going to plug in that password here so that when we go to VSCode, we can connect to SSH very easily. Again, SSH key is a more appropriate way to do things, again, in a more secure environment, but it's more difficult to teach. Then we come here and it asks you what password you want for that password, and I'm going to type in a password. You choose your password. You're going to plug that in, and again, try to make it relatively secure. You can come down, I don't think there's anything else here, and so then we're going to create our droplet, and it will take a second for our droplet to actually spin up here. So now our droplet has been spun up. So if we take a look at this, increase the size a little bit, we can see it's an Ubuntu, 1 vCPU, 1 gig, blah, 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 and this is going to be our IP address. So this is the IP address that we're going to be connecting to basically with VS Code to be able to start to do this deployment, and once we are done, this is going to be the IP address that's going to be used for your visitors to actually be able to access your web application once it's been deployed. So now we need to go to VS Code. Now one of the big things when you're using VS Code is to make sure you have the extensions installed that you need in order to do whatever it is that you're trying to do. So to have VS Code to be able to communicate with a server over SSH, you're going to need the SSH extension from Microsoft installed into your VS Code environment. So on the page here, there's a link to that, and basically when we go over here and we take a look, we can say we have remote SSH, and basically this is from from Microsoft, and so we're going to be using it. Do be careful if you're installing things like SSH extensions, because this is how you actually control servers that are in the real world. So again, getting it from some company like Microsoft, I may not trust Microsoft for a lot of things, but hopefully they're not going to be trying to hack my systems. If you go out there and you install an SSH extension from somebody on the internet, realize you don't know what additional programming has been added to that extension, and they may be hacking or compromising your system. So use whatever SSH extension you want, but I would highly recommend you use the Microsoft one there. Then basically what we're going to do is once that extension has been installed, we need to go to the command palette. So we need to do View, Command Palette, and what we're going to be looking for is remote-ssh connect to host, right? So basically if you're doing a search, you would do remote -SSH, obviously you're seeing it, so it's basically connect to host there, right? And then it's going to ask you who that you're going to be connecting to. That's where you go back over to DigitalOcean itself, and that's where you get this IP address. So this particular IP address is 146.190.129.10. I'm just simply going to copy that. There's a little thing that allows you to copy it. Then we come over here, and the first thing that we need to do is we need to type in root. So when you're connecting with SSH, you need to add the username that you're connecting with when you're doing the connection. So again, remember, with DigitalOcean, it automatically creates that root account for you. So we're going to do root at, and then Control V for that IP address. Root at 146.190.129.10, and then we're going to hit enter. When we hit enter, again, we'll see we come over to an entirely different screen, so we're going to be in that new environment. It's going to ask you whether you want to continue. It has a fingerprint, yep, continue. Then once you continue, it's going to ask you for that password that you created. So I'm going to type in my super secret password. And then we're going to hit enter. Let's see here. Download VSCode server. If you can see down here, it's opening the remote connection. So basically we can see app SSH, we have this kind of stuff, but down here it says SSH 146.190.129.10, so we know that we're connected to our server. From here, what we can do is we can open up a terminal window, and then the big thing here is when we look at that terminal window and we look at that prompt, we see root at Ubuntu S 1VP CPU 1GP blah blah blah, so we know we are on the server that we're trying to connect to. So we've created our Ubuntu instance, we've connected to that Ubuntu instance using VSCode over SSH, and so now we need to do the basic setup for our Linux environment. The first thing that we're going to do is we're going to update. So basically we're going to go to repositories and we're going to ask for what updates are available. So that's apt update, and again we don't have to use sudo because we're actually logged in as root. Then we do apt upgrade space Y. So basically this is going to upgrade everything. That's going to install all the new patches and everything. Always make sure you update a brand new system, because you do not know how many times you'll spend 5 hours troubleshooting a problem only to update the system and to find out some patch fixed the problem you've been like killing yourself over. Then we're going to install pip. So for whatever reason, by default pip isn't installed. So apt install python 3 -pip. Then we're going to install the virtual environment for Python 3, so apt install python 3 -vmv, and then since we're already here, we're going to do apt install nginx, so this is going to install that nginx web server for us. If we go over, again, we can just basically run through all of this at this prompt. Now make sure you're at the right place. So you'll notice when I came over, we're looking at this. This is on my system. If you look down here, there's no IP address or anything. If we keep scrolling over, we can come, and again, we see that we're at the system that we should be at. Again, that's one of the other big problems you run into, especially as a new administrator, is sometimes you get confused with what system that you're on, and then you start administering the wrong system, and that can be a bad thing, right? So we do app update from here, and again, we're all just going to do this in VS Code today. We're not going to go to a normal terminal window, and it's going to go through, and it's going to do all of the updates for us, and again, it just gives us our little prompt at the end, because that's how it should be. Then we're going to do apt upgrade space Y. So this is going to upgrade. This is going to update everything, actually upgrade everything, and we simply use a -Y to say yes, we agree to it, and then we're going to hit enter, and this will take a minute or two. So here we're going to get this configuring for OpenSSH server. Basically all you're going to do is you're going to hit OK here. Then we're just going to hit OK for that too. I just have it run through. And now we're done practicing our geek dancing while this happens, right? Okay, so we've done the update, we've done the upgrade, so all of that is installed. Now we need to install venv and pip, so we simply do apt install python 3-venv, so we can actually get access to virtual environments. And we're going to say yes. Okay, now that the venv is installed, now we need to install pip. So apt install python 3-pip. Ask us yes. More dancing. Okay, now we have venv installed and we have pip installed. So the final thing here for our environment is to install nginx. So we do apt install nginx, not z, nginx. We say yes. Okay, so now we have our Linux environment installed. We have the virtual server on DigitalOcean with Ubuntu, with Nginx. And how we're going to test all of this, because that's one of the things you have to do in life, is test to verify you didn't mess anything up. So I'm going to come back here. This is the IP address. So this is the internet accessible IP address. So what I'm going to do is I'm going to copy that, and I'm going to simply come up here to my web browser. I'm going to paste it in the web browser, and let's hope when I hit enter, there we go. That's what I should get. Welcome to Nginx. If you see this page, the Nginx web server isn't successfully installed. So I know it seems like everything is on my system here, but do realize this is actually going up to DigitalOcean, going to this particular IP address, and basically what we're seeing here is that Nginx works. It is able to deliver a web page to an external visitor, so we know basically our Linux stack up until this point is functioning properly. So now what we need to do on our Linux platform is we need to create a user account for our web application. So the name of the user account can be whatever you want it to be. Make sure it's something that's descriptive enough that you understand what is going on. And so basically what's going to happen is when our script runs, it will be run with the permissions of that particular user account. And this is one of those ways that you try to layer security to try to prevent a hacker from compromising your system. Do not run these web apps under the root account. So what we're going to do is we're going to use a simple command. It's called add user, and then the user that we want. So for this particular project, I'm simply going to call it app. Then past that, what we're going to do is we're going to add the app's home directory into our workspace, and then we are going to basically copy the files from our local system up into that DigitalOcean system so that we're able to interact with them. So basically what we can do is we can simply come over here. Again, make sure you know where you're at, right? So I'm at root at Ubuntu, right? So we're here, we're at the proper place. I'm simply going to type clear in order to clear the screen so you can understand it better. And what I'm going to do here now is I'm going to do add user, and then I'm going to call my user app, whatever you want. Then we're going to hit enter. It's going to ask for a new password. So you are going to need a password for this account. So come up with some super secret password and then write it down somewhere. Don't lose this password, right? So I'm going to plug in my super secret password. It's going to ask you to retype. I'm going to plug it in. Okay, password update changed successfully. Now it's going to ask you the full name. So I'm just going to say this is a web app. So this is just kind of like a logistics thing, so you can try to understand the different accounts on a system. Then I'm going to hit enter, room number, don't got one, work number, don't got one, home number, don't got one, other, don't care. Is this information correct? Yes. Do yes. If you say no or something else, you might run into problems, right? So now we have created the user account for app. So what we need to do now is we need to add this to our workspace, so we can just simply copy and paste files up into this workspace. So I'm going to go here for workspaces, and we are going to do open a folder. So here it's going to say root. So I'm in the root user, so I'm in the root home directory. That is not what we want. So what I'm going to do here is I'm going to go backspace, and then I'm going to type in home. So home will get me to the home directory. I'll do slash, and then we'll do app. So the only user account I have on the system is app. So I will click on that. So basically what we should see here is slash home slash app. And then we're going to say OK for here. We don't want to click on anything else. We want to click OK for there. And basically we're going through. Do we trust the authors? Yes, we trust the authors. Again, make sure you do that or problems will ensue. And now we see over here we have our little explorer. So we have the app folder, bash, logout, profile. So basically these are hidden files here. These are things that we don't have to worry about. So that is the workspace that is now open. Now to get files from our computer up there, we're going to do this the simple way. So this is in max screen mode right now, right? So I'm just going to bring it out of max screen mode. And what you're going to see is I'm at the desktop, right? So I've got requirements.txt, I've got the views, I've got the example, I've got all of that. Basically what I can do is I can simply copy the files that I want. So I'm not going to copy the VENV folder. I'm going to create a new VENV folder on the system. It just makes life a lot easier. So what I'm going to do is I'm going to simply highlight requirements.txt, and I'm going to highlight example.py because those are the two files that I care about. The example is the script itself, and the requirements are the requirements for the virtual environment. And then I'm simply going to drag them into this workspace and basically make my life easier, right? So now we can see that example.py and requirements.txt are now up on my web server. So what's going to happen now that the files are up there, requirements.txt and such, is what we're going to do is we're going to create a new virtual environment up on that server. So Python 3 space -m, VENV, name of the VENV is going to be VENV, and you're going to see a VENV file folder get created. Then what we're going to do is we're going to activate that VENV environment, that virtual environment, and then we're going to use pip to install everything from the requirements.txt file. Pip install space -r requirements.txt, and basically this will be able to install all of the modules into that particular virtual environment. So we're going to go back here. I'm then going to maximize from where we were. I'm then going to do terminal, and I'm going to do a new terminal. Just going to minimize this for a second, and we can see again we are back at the prompt that we had before. This is slightly different, so basically we now see we're at home at app, so this is the directory that we are currently in. I can do ls, I can do ls-l, and again this will show me that the example file is there and the requirements file is there, so that's what we care about. Let me increase the screen size a little bit. Again, this prompt is getting to be a little bit long. Anyways, so from here, what we're going to do is we're going to do Python 3 space -m space VENV, and then we're going to do space VENV in order to create that virtual environment. Got to take a second. So the virtual environment has been created. If we go up to Workspace, and we increase the size here, we can see we now have a VENV folder, right? So we're going to minimize this. We are then going to come down here, and then we're going to do source VENV hyphen /bin/activate, and that has now activated that environment. So we are now within our virtual environment. So from here, now we need to install the modules into that environment, right? So we're going to do pip install -r requirements.txt, right? Since we uploaded requirements.txt, that is now there. So what it's going to do is it's going to read that requirements.txt file, and basically we will install all of the modules that are in that file into our virtual environment, and we can now see that that's done. Once that's done, we can now actually try to run our example.py script just to verify that it actually does fire off. So from here, what I can do is I can simply pull up example.py, and I should be able to run it, right? So I can do Python 3 example.py. Since I don't have the run thing up here, because again, I'm up on that DigitalOcean server, so I'm going to use Python 3 in order to use Python 3 to call example.py. I'm then going to hit enter, and basically all we're looking at for right now is listening on 127.0.0.1 8080. So basically what this is telling me is that as far as bottle is concerned, this is running properly. So we know up until this point that basically that our environment is working right, bottle is working right, so everything should be working right up until this point. So once we've made sure that our bottle app is working up on our DigitalOcean server, we do need to hit the Control-C to kill it from here so we don't run into problems later. Past that, we then go to our instructions, and the next thing that we need to do is we need to create a service for the app. So this is where we're going to be using Gunicorn. Basically, we're going to be creating a Linux service that uses Gunicorn in order to access the bottle app and be able to present it basically to the port that we're going to be looking for. So here, what we're going to need to do is we are going to need to add another folder to our workspace. We're going to need to add etc systemd system to our workspace. So basically, if we go over and again, make sure we are at the right VSCode. We need to do a file. We need to do add folder to workspace. So we're going to click the add folder to workspace. So we have home again here. So we're going to go backslash. So we want the backslash, so that is root. Then we are going to go to etc slash. Then we're going to do sys dimd slash, and then we're going to do system slash, and that is going to be the folder that we are going to be opening up. So we then open up that folder, and over here in about a second it should show up for us. And we have the system folder now right here. So if we increase the size, you can see that we have the system folder here. So now what we're going to need to do is we're going to need to go over and we need to copy and paste all of this information here. So this is basically the service that we're going to be creating, and we're going to be saving it as app.service. So it's .service, whatever name you're going to be, it has to be .service, but then on the beginning will be the name of the service that you're creating. Again, for us, we're just calling this app, so we're just going to call it app. So let me copy. So I'm going to copy, Control-C, and then I'm going to come over here, I'm going to minimize, and we are going to hit Control-V in order to do a copy and paste, and then we are going to take a look at this code here. So basically, this is some basic information for our app. So we have a description of our app. What is this, or the service? What is a service? It's my cool app. When is this service going to get loaded? This is an important one. It's going to get loaded after the network services are up for the Linux server, right? So basically, when you reboot the server, you want to make sure that this comes on after the network services are on. So that's one of the issues that you can have when you create a service in the Linux world. If you start a Linux or a Linux service before the dependencies that are required to run the Linux service, it will keep trying to restart itself. It will then hit a failure point and then will stop, and then all the dependencies will start, and then nothing will work properly, right? So you want to make sure that your service is starting after whatever it requires, and that's what we have here. This is the service itself, so we're going to say the user, so the user account that this service should run under equals app, right? That app user account we created. The group user account that this should run under is www-data. So this is a group that's created whenever you install a web server software onto your Linux box. Basically, it's just a group for whoever is running the web server. Working directory. So basically, where is the working directory for this app? We're going to have home and app. Right, so /home/app, that's where all of our files are stored. The environment, we're going to do path equals home app venv bin. So this is the environment that's going to get loaded so that you get all those modules and packages and all that kind of stuff. This is one of the places that will have to be modified if you don't use a VENV, so I'd highly just recommend you use the VENV. Then this is the start. Basically, what command do you use to start? And so with this, let me get this out of the way. Basically, you do /home/app/VENV, right, because it's in VENV, bin Gunicorn. Right, so Gunicorn is that Python web server, so that is what we're going to be running. -- workers, so how many workers are you going to use? There's an argument here about how many workers you should use in the real world. We're just going to say 4. We're just going to say 4. Essentially, every worker that you have is able to do a task. So if you have multiple visitors coming into your site at the same time, you want more workers. There's this whole thing about workers and cores, and you can do a Google search on it. A good default for workers is 4. If 4 doesn't work for you, have fun doing some research. And then you're going to bind. Basically, you're going to be binding where will this web app be presented from Gunicorn. Not by Nginx for Gunicorn. So Nginx is going to have to grab this service to present it to the visitor. So we are going to bind this at 127.0.0.1, the loopback address, and then colon, I just put in here 8,000. You could do 8,000, you could do 8080. I like having the run, so when I showed you the script itself, the run was at 8080. Here for Gunicorn, I put it at 8,000. Again, just so there's not weird problems, weird quirks, right? And so this is going to be the command, right? And then we have down here, the final part of the command is example::app. So after all of this is in, example, right? That's the name of the Python script. The Python script that we're going to be running is example. So you leave out the py, right? So again, just to make sure you get this, again, this word wrap. So it's all the way here at the end, example, and then colon, the name of the app itself. Within the bottle script, what did you call the app? And so that's why it needs a name. And so we do :app because that's what we named within the bottle script itself. Then we have down here basically multi-user. So there's multiple users that are going to be going to this. And so this is the idea with this particular file right here. Then all we do is we hit Command S or Control S, save as, again, app.service. So this is going to be saved as app.service. Oops, make sure I put that in the right place. Oh, let's see here. So we do etc system d system, and then we do app.service. So we do have to make sure we put it in the right location. We don't put it in our home directory. So /etc/systemd/system app.service, and then we are going to hit OK here. And now that has been saved. And as you can see, it is now here sitting in that particular folder. Now, once we've done that, we have to reload the services on the server so that we can actually start this particular service. So let me minimize this, and basically I'm going to open the terminal again. So we can do this anywhere, so we'll just say that for app. And again, we get this nice prompt so we make sure we're in the right location. So from here, what we're going to do is we're going to do systemctl space daemon reload. So this is going to reload all of the services so the Linux box knows what services are available. Okay, now it knows what services are available. And so we're going to start the service. So and then we do systemctl start. So we're going to start the app. So this is actually going to start the app. And we're just going to get that. We're not going to see anything else, right? As long as everything goes fine. Then what we need to do is we need to enable the app. And so what enabling the app does, it says when the system reboots, make sure the service starts up when the system reboots. And so all we're going to do here is systemctl enable and then app. So this should enable the app. And there it says it creates the symlink. So now basically when the system is started, this will start up. The final thing that we need to do is we need to make sure it's like running. Because what happens if we fat finger? I know you wouldn't do it. What happens if I fat fingered this configuration file? We do want to make sure how it's running. So again, we do systemctl. We can do status and then app. And then we hit enter. And basically, what you're looking for is active running. If you get active running, you did a good job. You can copy and paste code like the big boys. If you get a red error here, basically what that means is that there is some issue in this. Most likely, you forgot to put in a double quotation mark, or you put a space where it shouldn't be. Again, the fun of being a technology professional. Right? Then what you have to do is once you figure out the problem, you think you figured out the problem, save the file, resave the file, do the daemon reload again. So reload, make sure everything reloads, then start the service again. Hopefully it'll work, do the enable, and then come to status and see if it's running. So at this point, we now know my service is actually running on this system, and when the system restarts, it will restart too. Now the next thing that we need to configure is Nginx, right? So we have the bottle app. Now we have Gunicorn. So Gunicorn will connect to the bottle app, and that will be a service when it restarts. Now we need Nginx to connect to Gunicorn. So within Nginx, an important thing to understand is that you can run multiple websites, or really multiple web apps, on the exact same server. So you can install Nginx, and there's something called vhost, virtual host. It's a different type of virtualization. We're not going to get into it today. But basically it allows you to compartmentalize websites. So just like you have a virtual private server that compartmentalizes an operating system, you have a virtual environment that compartmentalizes the environment for Python code. You can also have virtual host, vhost, and that compartmentalizes everything for a particular web app or for a particular website. Now, again, when you get into Nginx and you start learning about vhosts and running multiple sites off of the exact same server, that is quite literally a class for itself. So what we're going to do today is we're simply going to modify the default file, right? So Nginx has a file, the default file, that basically says what is the default website that we are going to present for anybody who comes to this site. And so all we're going to do is we're just going to modify that default file, and that's going to be good enough. Again, if all you're doing is running one app on your DigitalOcean server, that will work fine for you. And if you're doing more complicated things, then you can spend the time and energy to figure out how vhosts work. We'll talk about that, I'm sure, in a different class. But basically, the big thing that we're going to be doing is we need to go to the file that's called etc nginx, sites-available default. And so we're going to be modifying that file. When we get there, we're just going to delete everything that's in that file. There's already a bunch of code there. Get rid of all of it. And what I want you to do, basically for today, is we're essentially going to copy and paste this code, right? So what we're going to do here is I'm going to, let me just grab this. So I can grab this first, right? So I can go here. I can do File. I can do Open. It's going to ask me what I want to open again. And I'll just paste that in. So etc nginx sites-available default. That is the file that I want to open. And when I do, you're going to see this nice big old configuration. And the first thing that we're going to do is we're just going to delete it all. Again, there's a lot of interesting stuff here. We will go through it in a different class. We just want this deleted. I am then going to go over here and basically grab this code here and copy and paste it. So I'm going to simply copy. And I'm going to paste this code, and then we're going to talk about it for a second, right? So this is a server. We're going to listen on port 80. So again, port 80 is the default TCP port for web browser traffic, for HTTP. When you go to CNN.com, when you go to FoxNews.com or TacoBell.com, you don't have to put a colon at the end of it because port 80 is the default. They're presenting it at port 80, so you just go to the website. So again, you'll notice Bottle, we had that running on port port 8080, that's not the default. Gunicorn, we had it report running on port 8000, which is not the default. So if you set this up using Gunicorn or one of those ports, you would actually have to do :8000 in order to be able to access the web application. We just want somebody to be able to go directly using the IP address or again a domain name, and so that's going to be port 80. Server name is 127.0.0.1, so that's the loopback address. It's for this server. The location, so basically the proxy path, again we talk about this as a reverse proxy server, so we are going to be going to 127.0.0.1:8000, right? When we set up that Gunicorn service, we set that up on port 8000, so that's what we're going to be connecting to, and then we have a whole bunch of information here, and this is basically for again that reverse proxy stuff that we've been dealing with, so we're not going to mess with that. Again, a lot of copy and paste in the real world. Then past that, we're just simply going to hit Command, we're going to hit S, and that has now saved the default file there. Now what we have to do is make sure that our configurations are correct. Again, distrust, verify, always stay suspicious, and so one of the things we can do is we can come up, we can create a new terminal. Just do it in the app directory, it doesn't matter. And then we run the command nginx-t. What this is going to do is it's going to test to make sure that your configuration file is okay. Syntax is okay, test is successful, so it should be good to go. Then what we're going to do past that, so we've got this prompt here, so we want to restart the service. Again, system, ctl, restart, Nginx. Again, whenever you make a change to the Python or to the Linux system, always restart whatever services that you've modified. When in doubt, restart the entire server. It'll make your life easier. And so now we are restarting the entire server. So now all of this should be up and running. So now is the nerve-wracking part. And it's not just a nerve-wracking part for you as a noob, it's actually a nerve-wracking part for me as a person that's been teaching you. Because it just took me like an hour to film this class. And if this doesn't work properly, I'm going to redo the entire thing. So let's cross our fingers. So we're coming back to our DigitalOcean dashboard because what we care about here is this externally, or this internet IP address, all right? Internet accessible IP address, 146.190.129.10. So if we go to that in our web browser, we should get a message that says hello world. So I'm going to go here, just make life easier. I'm just going to copy that. I am going to come up here, create a new tab. I'm going to hit Control V, 146.190.129.10, and we are all going to cross our fingers. I'm doing this live. I hope this works. Oh, and look at that. It worked. I amped up the tension for you, and now you can see it is all worth the effort. We have our Hello World app. We are one step closer to making our $1 billion. Again, just to show you, again, this is the real world. So if I pull this up, let me pull Safari up on my little iPhone here. Oh, I plug in 146.190.129.10. I hit enter, and look at that. Again, that is now accessible using my iPhone. We have now told the world hello. So we have made it to the end of the class. You and I together have gotten through this misery. I know on your side it's been hard. Oh, believe me, creating this class has been a bugger on my side too. Again, there is a difference in the real world of technology of like being able to deploy something and then being able to teach somebody to deploy something, and then being able to document all the steps so that new people can try to deploy something. That is its own skill set right there, right? So basically we have our nice little bottle web app that says hello world. We have Gunicorn on an Ubuntu Linux server hosted by DigitalOcean that is able to connect to that web app. We then have Nginx that then connects to Gunicorn, and then whether somebody has a phone or whether somebody has a normal computer or whatever else, wherever in the world they are, as long as they're able to access that particular IP address, they too can be told hello. So that is basically how it works. Again, when you want to get into more complicated things, I don't want to get into that today, when you start having more files and folders and that type of stuff, the only difference from what I've taught you through this entire series is simply you're just going to have to make sure the Linux permissions are appropriate. Again, and that's where we talk about being a full stack developer and why being a full stack developer is important. Is a full stack developer knows how to create that front end, knows how to use a framework and a back-end language to give things functionality, knows how to use SQL, something called structured query language. We'll have classes on that later. Understands how to use things like data stores, understands how to use Linux and how to administer Linux, and that the idea with a full stack developer is that they should be able to deploy the entire thing. They should be able to throw the entire app out so the world can see how amazing they are, and that's the idea of what's going on. So if you want to get to this point, you should start to learn more about Linux because it will be important. As with most of this stuff, Linux is not that hard. We will have a series on Linux in the future. For me in the future, for you it might already exist. Might be old at this point, but anyways, we'll have that series. Linux, like all of this stuff, is not difficult. You just have to learn how to install it. You have to learn how to do some basic configurations, that kind of stuff, and it's actually pretty simple. The big issue that people have with Linux is that it's mainly just command line, and so you either type in the right command or you don't. And that's what gets people to be a little when it comes to using Linux. Beyond that, for this, again, we use the DigitalOcean simply because I like DigitalOcean. Again, the default for Silicon Dojo is just going to be simple, what a lot of people use, affordable, that type of thing. And so, yeah, DigitalOcean is like the Kleenex of virtual private servers. Again, especially if all you're doing is deploying a project, deploying a demo, I don't really see how you can go wrong. If you do want to deploy this to a different type of system though, let's say you want to deploy this to your own server, again, the only difference there is you just kind of have to understand a little bit about those Linux configurations. If you are running this on your own server, again, you install Ubuntu, you'll have to run the sudo command in order to make sure everything runs properly. That'll be about the only difference there, right? Some of the other things, again, when you start talking about ports, firewalls, so if you're running your own Linux server, making sure that firewalls are closed off, that's going to be a big deal. You know, there are some simple things in there, but basically everything that I've shown you today, this all translates to any Ubuntu box that you're going to use. DigitalOcean, Linode, your own system that you set up. Again, with a few incredibly minor modifications. So there. That's all it is. So I enjoyed teaching this entire series to you. I hope you now understand how to create a web app using the Bottle web app framework. Again, Bottle web app doesn't come with all the bells and whistles of Django and other web app frameworks out there, but on the good side, it also doesn't come with all the bells and whistles that you have to figure out how to make it work. What I love about Bottle is literally you can run through this series of classes. You can literally just run through the notes of these classes, and within a few hours, you can have a little web app up and running that will not be that difficult. Again, when you go into the quote-unquote production environment, whether or not you use Bottle, that's a bit of a question. But honestly, again, one of the things you have to think about is, what is your definition of production, right? If production is 10 users an hour, Bottle's fine. If production is a few hundred users an hour, Bottle's probably going to be fine. You know, production is like 1,000, 10,000 users per hour. That's where you have to figure out where is the line where you should move over to a different framework. Again, you start thinking about things like scalability. When you want to maintain, again, a large code base, I would not want to create a large code base with Bottle just because of how it's designed. That would be a bit of a bear to actually work with. Those are some of the kind of things you have to think about with the Bottle web app framework. But there you go. That's a series. I hope you have fun using the Bottle web app framework. We're definitely going to have a lot of projects and a lot of labs in the future using this, and that's one of the reasons that I created the series. So hope to see you at the next classes.